We good? Hey class, how's it going? I'm gone today, obviously, so we're already a couple days behind, so we're just going to watch this video. It's going to be the same notes for 7.3, and well, here we go. Alright, so 7.3 is solving linear systems by linear combinations. Yesterday we worked with substitution, so solving for x or y and then just plugging it in. We're going to do something kind of similar to that, but now we're just going to do it with linear combinations. Okay, so how we want to look at these is that we want to treat them as it's one big equation. Okay, so as you'll see you have a negative x here and a positive x here. So if I do something like this and I add these, all you have to do is you add like terms like we always have, right? So negative x plus x is going to equal 0. So that's gone, which is good, all right? And then 2y plus 6y is a positive 8y. Negative 8 minus 16 is negative 24. All right? So now we have 8y equals negative 24. Now we just got to get y all by itself. So we divide by 8, divide by 8. Y is then equal to negative 3. Okay? But we're not done because we need to find x. So all we do, like we learned yesterday, is just plug a y into either of those and solve for x. I'm going to plug it into the positive x because it makes the most sense so that we don't have to divide by negative 1 here. So here we'll go x plus 6 times negative 3 equals negative 16. And then we'll just simplify, get negative 18 here equals 16. This is like x minus 18. Okay, and we're going to add 18, x is going to equal a positive 2. So our solution is 2, negative 3. Okay, good. All right, and if at any point you need to pause the video and rewind so you can watch this, go ahead and do that. All right, you're getting the math too, right? Okay. All right, example 2. Now we're going to do something very similar, all right, where we could do substitution and solve for y or solve for x, or we can multiply by something, okay, to get these two things similar so that we can cancel out one of these variables. That's the biggest thing with this section, is that we're trying to cancel out one of these x's or y's. Okay, so if we look at 2x and 5x, they're not really multiples of each other, so we're going to want to move to the next variable. 8y and negative 4y, those are multiples, okay? So we can multiply negative 4 by 2, so we'd actually multiply this whole thing by 2 to get it so that it's at 8y. So if we do that, we distribute just like we would any other time, okay? And we get 10x, because 2 times 5x, minus 8y equals 6, okay? But we didn't do anything to this bottom one, so we can just leave it like this. Okay? Now the same exact thing happens. Where now, if we add negative 8 plus 8y, negative 8y plus 8y will give us 0. And that's exactly what we want because now we only have one variable. So 10x plus 2x is 12x. 6 plus a negative 2 is like 6 minus 2, so equals 4. Ooh, forgot the x there. So now 12x equals 4. Divide by 12, divide by 12, x equals 4 twelfths. Okay? But now we got to simplify this fraction. Okay? Because it's going to be easier to plug it in if we simplify it down. What goes into both 4 and 12? Yep, you guessed it, 4. So we'll take 4 out of that. So 4 out of 4 is 1, okay? Take 4 out of 12, and that's 3. So we have 1/3 for our x value. Now all we have to do is plug that in for our y value, for our x value and solve for y. So I'm going to choose this bottom one. So we get 2 times 1/3 plus 8y equals negative 2. We get 2/3, because 2 times 1/3 plus 8y equals negative 2. We're going to minus 2/3 minus 2/3. Okay, so we get 8y equals. Now here's the tricky thing when you're subtracting fractions. What most of you are going to do is probably just do a decimal. So that's what I'll do right here. Is 2/3, if you put that in your calculator, you're going to get 0.666, okay? But when we're subtracting from 2, we're going to get negative 2.6666 repeating on forever and ever. All right? So now to solve for that, we would divide by 8, y equals negative 2.66 divided by 8, and we get negative 0.33325, okay, which is very similar to 1/3. So we either are going to want to write them all in fractions, or we're going to want to write them all in decimals. So because we have two decimals, because we have that decimal in this fraction, we know this fraction is 0.3333, right? So why don't we just go ahead and write them as fractions? All right, let me rewrite that. Repeating, and y is negative 0.3325. Okay, if you need to pause and rewind, all right, I will also be there tomorrow to help you out with this. Okay, this is a tricky one. Oops. All right, now we have an example where it's 3x is equal to something instead of being in standard form. This is a form that we haven't really seen. So what we can do is we can just solve for x and substitute it in like we've done in different problems. So that's what we'll do. So for this one, you would actually divide everything by 3. Okay, because you're trying to get x all by itself. So x is going to equal negative 6y divided by 3. Negative 6 divided by 3 is negative 2, and then you can't forget the y, plus 12 divided by 3, which is 4. Okay, so now I can take this x and plug it in. All right, so sorry about that. The last video I ran out of space on my phone, so I had to clear some up, so we're continuing on this last piece. So if we divide everything by 3, we get x equals negative 2y plus 4. Okay, so this is equal to x. So we're going to plug this whole thing in for x. But don't forget this negative symbol. So it's going to look like this. Negative 2y plus 4 plus 3y equals 6. Okay, but we have to distribute this negative. Okay, it's like a negative 1. So negative 1 times negative 2y is going to be just positive 2y minus 4, because negative 1 times 4 is negative 4. Plus 3y equals 6. Now, all we have to do is